Hello everyone, this is Captain Zeewala, or actually I'm going to change my name from Captain Zeewala to Commander Zeewala. And the only reason why I'm going to change my name to Commander Zeewala is because we're going to be doing our very first space flight today. So welcome to Orbiter 2016. Before I even start and get into all of this, I want to first give a shout out. I'm going to give first names, obviously no last names, because I don't want you looking these guys up on the internet unless they want to be looked up on the internet. But I'm going to give a shout out to definitely my buddies Justin, Rowell, Mike, and my buddy Jay. They continuously put up with my nonsense and my videos that I sent them. They have very little interest in the subjects, but they try to learn as much as possible. So I want to go ahead and give a shout out to you guys. So this first video is dedicated to you. And I just want to say thank you. Anyway, all right. So let's get into it. This is Orbiter 2016. And let's see if I can tab over. So here it is, Orbiter 2016. And this is the space flight simulator. It's the 2016 edition. And I want to go ahead and show you something, guys, right here. See that? That's the word free. This program is absolutely 110% free. All right, it's been around since the early 2000s. I've actually had it. I've actually downloaded it before. I've actually messed around with it, but I've never actually sat there to kind of read the manuals, watch some tutorials, and try to learn. I'm really into spaceflight, especially the old Apollo missions. I know it pretty damn well, and I'm kind of somewhat obsessed with it. So this is something that I should have been getting into a long time ago, but it's never too late, folks. It's never too late. So this is a really awesome program. It's down to the T. The physics are down to the T, absolutely. It's community-based. There's a lot of add-ons for it that make this actual simulator take it to the next level and adapt some realism to it. You can do historic flights. You can fly the space shuttle. You can download additional aircrafts. And do a whole bunch of missions. So for it being free, honestly, it's like I definitely would definitely donate and contribute. And oh, look right here, here's a donate button. So if you do decide to download this game or simulator and you have a PC and you mess around with it, donate. It's absolutely 100% free. It's community based, and you get to mess with a game that I would gladly pay 60 to 80 bucks for. And I shouldn't say that, because if they watch it and they start charging 60, 80 bucks, you guys are going to blame me. So anyway, let's go ahead and get back into Orbiter. We are right here in Orbiter. Beautiful Cape Canaveral, as you can see. We are sitting right in front of runway 33. Now, the only thing that sucks is that I can't really zoom or move out and go exploring in other areas. So where my aircraft is, or spacecraft actually, wherever that is, I'm actually stuck at that particular point. So that's it. That's where it is. So let's go ahead and zoom out so you guys can see. They're using photo scenery. You can see that right here, which is not bad. Probably look on a zoom level, I say 17 out of everything. So it's not bad. Remember, it's free. It's 100% free. So we're sitting here in Cape Canaveral in Florida. Right over here, where my mouse is at, this is where they store the shuttle, the old Apollo rockets. I mean, any new rockets, they store it right here. And then what they do is they take this nice little mile journey down this way. And then here's pads 39 A and B, and this is actually where they lift off from, okay? And then as they come in through the approach, this is where they land, right over here. Okay? So that's not bad. Look at the sun reflection on the water there. It's not too shabby, man, for being a free simulator game. Okay? I'm pretty happy here. All right. So now we're getting down to our aircraft here. Spacecraft. I got to say spacecraft. I do a lot of flight simulators, so I'm going to say aircraft a lot. So got to change that up, folks. Got to change that up. All right. So this is known as the Delta Glider. Okay. And it is the beginner aircraft that a lot of people use, including myself. It's a very forgiving aircraft. Spacecraft. I'm just going to say what it is. But it's a very forgiving spacecraft. It's very easy to fly. You can get into space super, super easy with this thing. As long as, you have some basic general knowledge, you'll be good to go. All right? And that's going to bring me to my next point right here that is the objective today. The objective today for us is to get into space and then achieve an orbit. Now, I don't want to make it too difficult or anything like that because I am learning. So as I learn, you guys are going to learn with me. Okay? So as I start advancing forward, you guys will start advancing with me. And I'm going to make mistakes along the way. Nothing's going to be perfect. There's probably going to be doing some things that I'm not supposed to be doing, but this is what these series are about. This is what YouTube is, and this is what's so great about uploading videos to YouTube is that you can have people comment and flame on you and be like, hey, Captain Zeewala or Commander Zeewala, you are not supposed to hit that button. You're supposed to hit this button. So this is what it's about, folks. All right? So enough of me chatting. As always, I love to ramble. Let's go ahead and hop into our aircraft, spacecraft, whatever craft, by hitting F1. And we are in here. I'm going to zoom out. Now you can see right here, not bad. Got your pilot seat right here, or your commander seat right here. And everything is working in here, by the way. This is not something that's just, it's just like a 2D cockpit. Everything works. So if I was to click buttons here, see that? Cape Canaveral shows me my exact location where I'm at. The ISS, where it's at. Mir, where it's at. So there's working things. Everything works in here. I'm talking about everything. All the buttons work.
Translation, rotation, attitude off.
Okay, everything works in here. I don't want to touch anything else, but everything else works in this particular unit and in this particular spacecraft, okay? If I turn around here, I got my two buddies back here. And if I turn around this way, I got my lady friend back here, all right? Are we going out? I don't know. You guys can decide on that. Maybe, maybe not, okay? All right. So, and then I'm going to go ahead and press F8. And that's going to take us to a couple different views. This is the 2D view. And if I hit the down arrow key, you can see that all the actual buttons that were on our 3D panel is right here on our 2D panel. So if you want to fly this way, you can. And you can get it out of the way like that. And then you can go back and do it this way, which what we're going to do today is we're going to use this actual view because it's going to be 10 times easier to explain. And it's just all around simpler. The more you see, the worse it's going to get. So, let's go ahead and explain what we have on our screen. I know a lot of things look confusing, and we'll start from left to right, and then we'll just kind of work our way around. All right. So what we'll do is I'll actually turn all this stuff off. You can hit the power button, turn it off. This way, it's 10 times easier for you guys to see. All right. So the only thing that is up here is this little panel here off to the left, and it's showing us our main propellant, what we have, and it's measured in kilometers. Okay. And for our scenario, we're going to have an unlimited amount of fuel because I want to make this, once again, as easy as possible. All we're trying to do is get into space and achieve an orbit, okay? This is our main engine, which basically provides us thrust, pushing us forward. This is our hover engine, okay? So we have two engines on this thing. So if I come out of here, one you can see, all right? This is one unit right here. Now, if I go to the bottom down here, I don't know if you guys can see that, but we also have hover engines right here as well. So we can hover like a helicopter, and then we can also like do a lift off where we can lift off from a pad and go straight up, and then we can turn on our main thrusters to move us forward if we like to as well. We can also use the hover thrusters like a helicopter and pitch forward, and that will actually make us move forward. Now, the physics on this thing are so awesome that because we have so much propellant, even if I was to turn on my hover engines to full throttle all the way, we wouldn't go anywhere. And the reason being that is that we're so heavy. So this is what I like about it, that it's, it's realistic. It's very realistic. It tries to be as realistic as possible. All right? Okay. Now, let's go ahead and turn on our heads-up display by hitting H. Nope, that way. Okay. So what is in our heads-up display? All right. So right here right over here, this is our true airspeed. This is measured also in meters per second. All right. This is our heading indicator. Okay. Works just like any other heading indicator. Measured in degrees, like a compass. Off right here to our right-hand side. This is our altitude measured in kilometers. Okay. This is our attitude indicator. Now, I don't know if you can see this right here. But I don't know if you use Alt and H, can you change the colors? You can. Okay, cool. Blue, green. So I'll do this orange so you guys can actually see what's going on here. So right here, this line right here is our horizon indicator. So see how this line is right here on horizon? Well, that's basically us telling us that we're actually straight on the horizon itself. See that? Just like any other aircraft that you fly, you have your horizon, your attitude indicator telling us exactly where you are. Okay? Boom. Now you have levels of pitch. Okay? Obviously plus 10, 20, 30, 40. These are in degrees. All right? So if the aircraft is pointed to 10, 20, 30, and 40, you know you're at that particular degree of pitch. And then obviously vice versa. Negative 10, 20, 30, 40. Same thing. Negative level pitch. Of course, obviously, if I'm in a positive, I know I'm going to be in a climb. If I'm in a negative, obviously, I know I'm going to be falling down back to the earth, right? What else? Okay. And what are these 1, 2, 3? This is just basically your gear. It's telling me that all 3 gears are down at this particular moment. When the gear goes up, all these will go away. They'll actually flash. So watch it. All right. Now, what are these buttons here on the bottom? I have no idea. Thanks for watching, folks. Have a great day. All right. No. So, we won't get really too much into it, but these are our autopilot buttons. If I was to press one of these buttons, it would move our spacecraft into a certain state. It would put us into a certain formation, and we use these formations to perform burn maneuvers in space in order for us to either climb, move left to right, decelerate, and do re-entry, blah, 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 blah. And we're going to use one of them today, so when that time comes, we'll use it, all right? What I didn't explain is this RCS right here, okay? Right now it's off. It's got rotation, and this linear, this is called translation, all right? So what do these things do? All right, well, as we start to climb up and we get higher, we'll have less surface air for us to actually interact with, right? So what we need to be doing is obviously, and especially when we're in space, we have no air at all. There's no atmosphere. Space is a vacuum. We need to move around. And so what we do is we turn on our rotation. Right? So these are our attitude indicators. We turn it on. And so what happens is that when we do that, the little thrusters will start to fire as we move. So there you can see these little holes right here. There's one right there. There's one right there. And there's a bunch on this aircraft. There's 2 right here. There's 2 right here on top. There's 2 on the bottom. Okay? There's one right here on the left and one right here on the right. So these things obviously would move us left, right, up, down, side to side, pitch, bank, and yaw, right? Right now, got my yoke. Right now, I'm acting like an aircraft. So if I go left, you can see the ailerons move up. Go right, you can see it move right. Down, you can see it move down. And then up, you can see it move up. Now, if I was to turn on this and do it, now look carefully. Oh, what is that? See how the thrusters are moving? See that right there? See that right there? All right. So that's what the rotation does, is it turns on the thruster. So if I was to move left with the yoke, and it does it also, look, it's a little bit. Now the more I move the yoke, the more intense it gets. So the more thrust it's on there. So, it'd move us in space. So what does this translation do? Well, it's smaller maneuvers. because obviously sometimes you don't want to make a humongous move out into space. You want to make a very small maneuver. So that's what the translation does. And it's very tiny moves. Like, see, right now I'm moving it, but you can't even see it. But it's on. Okay? You can see that one right there. But the left and the right, it's not there. Now I would use very small maneuvers by tapping on the 4, 6 key, 2 key, 3 key. If I was to press the numbers on there, it's very tiny little spurts. Tiny. Spurt. All right? So that's what that does. Okay? So we'll turn it off because we're going to be interacting with the air. And I'll turn this back to green. The green with the green. Okay. So let's go ahead and turn off one of our MFDs, which is our multifunction display. So we'll turn one on. And what we're going to do is, this basically has, if I hit select, this basically has a whole bunch of menus that display certain things that I want to do. Right now, all I want to do, remember, is to get into space and achieve an orbit. So can you guys guess which one I'm going to pick? Get into space and achieve an orbit. So I'm going to hit the orbit one. Okay? So here it is. This is the orbit, and I'll explain what this is in a second. The very first thing I'm going to do is I'm going to hit this project. Okay? This right here. This gray line. Gray circle, actually. Take it back. This is the planet Earth. Okay, this dot right here is the center of the Earth. Okay, this is a projection of our orbit. Right now, we have no projection of our orbit. We look like a squished grape right now. Okay, we have no projection of the orbit. So we are trying to achieve an orbit. So this projects us. So as we start moving, as we start gaining speed, as we start gaining altitude, this will start to open up and you'll see it. It'll start to expand. It'll start to get bigger. And what we want to do is we want this circle, this little squish circle, obviously first to become a circle, and then we want it to overlap the Earth, right? We want it to overlap the Earth. This is going to show me that I'm in a orbit, a correct orbit, all right? So we want to do that. So the very first thing I want to do is I want to hit the project button because it's not set to the ship. It's actually set to ECL. Don't worry about what that sounds right now. But I'm going to hit ship, and obviously that's going to show us right there. Now, this right here, the gray line, this is the surface of the Earth. This is right now what we're on, what we're sitting on right now is this gray line. Okay, this gray line right here is where we're sitting on. The way this is measuring right now, is it's from the surface of the Earth to wherever I'm going to be. So if I'm, 10,000 feet in the air, it's going to measure from the middle of the Earth to 10,000 feet. And I really don't need to know what's in the middle of the Earth to 10,000 feet. I don't want to measure it that way. I want to measure it from the surface of the Earth, to wherever I'm at. Okay? From the surface of the Earth to wherever I'm at. So I'm going to hit this DST button. And this is known as distance. Now, this is changed. Okay, some numbers moved here on the left-hand side. And now I'm measuring from the surface of the Earth to where I'm at. Don't worry about these numbers. Don't worry about these numbers right now. We're only going to learn a couple of them today. And that's all you need to know. Don't worry about these numbers. Okay. Now, I could technically fly out this way. But we're not going to. I'm going to go ahead and turn on the other multifunction display, or MFD. And I'm going to hit the select button. And I'm going to click on the surface display. And people are used to seeing this right here. Okay, people are used to seeing this right here. So, of course, this is our altitude measured in meters per second. Okay. No, sorry. This is our speed. I take that back. This is our altitude. Okay, kilometers. And this is our vertical speed measured in meters per second. So, what are we doing per minute? Okay, meters per second. All right. Okay, so that's all you need to know. Don't worry about all this stuff on the bottom. Just worry about this. So you guys are all used to this, seeing it. So it's just a lot easier on the eyes. Of course, this is our attitude indicator showing us, see how we have a straight line right here, and we have a straight line right here. And if this was banked to the left, this line would be banked to the left. And look, here's the level of degrees, 10, 20, 30, 10, 20, 30, 40, 10, 20, 30, 40. It's on the bottom too. All right, bada bing, bada boom. Now, let's go to space now. Now you got everything turned on, Commander Zeewala. You've been talking for quite some time. Let's go ahead and get into space. Not that easy. Or is it? Well, let me first clear up a myth, okay? And I'm going to zoom out here for a second so we can see the pads again. How do you get into space? Well, if you ask any kid, or even if you ask me years ago, I wouldn't know. I wouldn't really know. I mean, I had a general idea, and most people have a general idea how you get into space, right? So what people normally say is like, oh, okay, the rocket takes off, it goes straight up, and once it goes straight up, it reaches a certain point where gravity is no longer acting upon the aircraft. It's not pulling it back to the ground, and it just stays up there. It gets stuck up there. Well, yes and no, kind of. Okay, yes and no. Yes, we do need to go as higher and higher. And once we go higher, yes, there will be less gravity pulling upon the actual aircraft itself and less air to interact with. And when we'll be in space, there's going to be no air. It's a vacuum. We'll be stuck up there. Bada bing, bada boom. Kinda. Okay? I want to go ahead and show you guys a picture. So I'm going to go over here. Click on this. Now, here is a shuttle taking off. I believe it's the shuttle. Now, if you see how it's taken off, can you zoom in? I can. Oh, that's too much. Zoom out. So you see it takes off. It goes straight up, just like you see it all the time. All right? Because this is the projected path that it took, by the way. All right? So you see it was out of a time lapse, by the way. So here it is. You see it taking off. All right? But then you see it's kind of pitching over. And then it gets almost parallel. And it's headed out towards the east, by the way. All right? So you see it taking off, going higher, and then it pitches over, and then it's headed out to the east. So why is that? Well, it's because the Earth spins from west to east. Okay, this is the direction of our spin. Remember, it's sitting on an axis 23 degrees, and the Earth spins from west to east. Okay? And how fast is the Earth spinning from west to east? The Earth is spinning around 17,500 miles an hour. Pretty damn fast. Okay? What we need to do is we need to spin with the Earth. Okay? And we want to go as fast, and we need to achieve what is called delta V. Okay? And we need to break that gravitational pull that we have. Okay? And have enough velocity and speed that we break the Earth's gravity and we get into space, all while actually raising altitude while we do it. Okay? So we're going to do the same thing too, except for us, we're not going straight up. We're in a rocket. I mean, a spacecraft, right? Sorry, not a rocket, a spacecraft. We're going to be taking off, and then once we take off, we're going to make a right, and we're going to head to the east. Okay? Because, why? Because the Earth is spinning right from west to east. As simple as that. Okay? So here we are back again. Hopping back into the aircraft. I'm sitting at 330 degrees. I'm almost pointed to the north, a little northwest. And what I'm going to do as soon as I take off, I'm going to get it to a nice safe altitude. I'm going to bank a right, and I'm going to head to 90 degrees. 90 degrees is east. Okay? And once I'm there, then we'll start making a climb, and then we'll head on out, and we'll get into space. Okay? So the numbers that we're looking for, now remember, we have to achieve delta V. Numbers we're looking for, we want our true airspeed to be somewhat around 7,500. Okay? 7,500 meters per second. All right? And our altitude will probably be around 100,000 to 120,000. Should be around there. Okay? All right. So, now the fun begins. So I'm going to go ahead and make sure everything is set. Okay, folks, I don't know what happened to my audio right there, but I tried fixing it. So if you see or you hear a little bit of a difference between the audios, my sincere apologies. So anyway, all right, so let's go ahead and get fun and get into space. And enough of us chatting. We've been chatting for the last 25 minutes or so. So let's go ahead and engage the thrusters here. I'll go ahead and turn the engines on, and it should come up. Aha. Okay, so the engines are now on, and if we come out here, you can see it. All right, engines are on, ladies and gentlemen. Fasten seatbelt sign has been turned on. Ding, ding. And you guys are all strapped in. Let's go ahead. Now, it's going to get a little bit loud. I tried to adjust the volume as much as I possibly can, but the thrusters, for some reason, are the only ones that don't get adjusted. So we're looking for our rotation speed. We're looking for 185 meters per second. So I'm going to go ahead and advance the throttles forward. And there she is. And we are at full throttle. We are advancing down the runway. And we are just waiting for us to rotate. Just make sure I move my microphone here out of the way so that I'm not bumping into it when I pull back on the yoke. And there's about 185. I'm going to slowly pull back on the yoke here, and she should take us right up, and there she is. Beautiful. And we've achieved enough altitude. I'm going to hit the G button, and the gear's coming up. You can see the flashing lights here. Got my
Radiator retracted.
All right, and now remember, we got to go to the east, so we're going to pitch over. And that's something that I did not let you guys know as well. If you listen to any of the missions, you know, if they listen to any of them and where they talk about getting into space, like especially the Apollo ones or the shuttle or any rocket, you'll hear them say at one point, pitch over or roll over. And what they're basically telling you is that, okay, it's now you need to point your direction over to the east, and that's exactly what we're doing right now. We're pitching over, we're rolling over, we're turning our way to the east. And how do I know I'm doing that? Well, you can see the compass moving, our heading indicator that's moving, and that's basically showing us that we are making some progress here, and we are heading on over to the east. I'm going to slowly start the rate of turn here. And I'm going to take it to around 80-ish. All right, this is fine, 80, 85. It's not perfect 90, but it heads out on over that way anyway, okay? So here we are. All right, okay, we just passed some atmosphere right there. I don't know if you just saw that, folks. All right. Okay. Now, let's go ahead and straighten out here a little bit. All right, now we're somewhat straight. Now, I know right here, and well, this is kind of hard to see here. Let me change the color here. I think this is a good color. This orange is a good color. Now, you can see this is the horizon right here, right? It's the horizon right here. And I can tell that I'm in a climb because my horizon line is above the horizon. So I can tell, even if I turn this off right now, I know that I'm in a climb, okay? I know I'm in a climb. All right? Okay, so we're going to turn that back on. We're going to try to straighten it up as much as I possibly can. Okay, and this is, I know I'm climbing right here because it's just showing me that I'm in a positive climb. My speed is coming up. If we hop outside the aircraft, wow, look at that beautiful sun, huh? Look at that beautiful sun. And we go back here and we look back here. That's exactly where we took off from. There's the runway. This is Cape Canaveral. Here's the pads 39A and B, which the shuttle takes off from, or it did, and now it's retired. But we'll hop back into our spacecraft. And the sound works really weird, too. There's nothing here. You go back here, you can hear it, all right? So you can see I'm not crazily pitched up all the way to the sky. I'm somewhat pitched, but I'm not, like, super pitched up. I'm making my climb up into space. Now, you're also going to notice a couple things as well. There's going to be a pink glow that's going to happen right over here, all right? And that's going to be the molecules heating up because we are interacting with them and we are going fast. So the faster we're going, the more intensity is going to be achieved by our particular aircraft, and the hotter it's going to get. So we're going to interact with those molecules as we go higher, and there's going to be the gases that we're interacting with, and that's going to be the byproduct is going to be a pinkish type of glow, and you'll see that happen once we hit around 17 to 1800 meters per second. So we are still climbing up. This is starting to descend down. And now look at our circle, folks. Look at our circle. Now you can take a look at our circle, and you can see that our circle is starting to grow. It's starting to expand here. It's starting to get bigger. Remember, the objective is for us to take this circle and overlay it on our Earth. All right? And that is the objective that we need to do. Which is not bad. All right, so we're starting to come down a little bit. You can see the rate is dropping down quite some bit. But the speed will start coming up as well. All right, we're watching everything. Now, notice the sky as well. I'm going to add some trim so that this goes back up into a positive. And all that is it's adjusting it so I'm not pulling back on the yoke all the time to put us in a positive climb. Now, if I turn this off, you will start to see the curvature of the Earth, which you see right here. And you'll see the sky turn from the blue that it was just a brief moment ago. The blue that it was, now it's turning into this darker midnight blue. And as we go higher, it'll go from blue to black. All right? So we'll turn these guys back on here. So we're coming up on 2,000. Okay? And our altitude is coming up on 30,000 kilometers. I turned my HUD off. Oh, actually, I didn't. Now I turn it off. All right. So I am not forcing it. If you take a look at it, ladies and gentlemen, I'm not forcing this thing at all. I'm just slowly accelerating up. Okay, come back out. Oh, there you go. You can start to see the pinkish or orangish glow that's starting to happen. We are interacting with the gases above. We are getting faster. So you can definitely see that the aircraft is getting hotter. And I have to stop saying aircraft. But the sun looks beautiful on that water, huh? Looks great. And you can see the curvature. And you can see that we are climbing up. So we'll hop back in here. All right, starting to decelerate down here, the climb. Which is quite fine. And the numbers that we're looking for, remember again, 7,500, somewhat close to 7,500 for our true airspeed, TAS, okay? And then over here we're looking at probably about 120,000 for our kilometers, okay? Above the Earth's surface. So from the surface of the Earth to where we'll be at, this is the measurement. All right, so I add a little bit more trim. So this should put us back in a positive climb. We're at 3,000. And you can see, I really hope the audio comes out good. I don't know at this point. Okay, so you can see it's starting to turn blacker. This line is above the horizon. Now the horizon is actually starting to curve, right? So that's the curvature of the Earth. So it's no more a straight line because we were more closer to the Earth's surface. But as we go higher, we can see the climb. I mean, we can see the curvature. So, but we can still compare it to the horizon. So it's above it, right? It's above it. And it's showing us that we are in a climb. All right? Let's look at our circle here. It's getting bigger. All right? Now this line right here, I don't know if I explained that or not, but this line right here, this line is where we are at currently on the Earth. Okay? This is the Earth's surface. And this is the middle of the Earth. So it's measuring. So you can see as we are going forward, this is starting to move forward as well. And then once we achieve orbit, you'll see that this line will start to move around the planet. Okay, and that's basically going to give us our position. All right. So we are still climbing. All right. Not touching the yoke too much. Just making some adjustments, some tiny adjustments here and there. All right, she's starting to fall back down, which is okay. This number's starting to come up. We're going to be hitting 5,000 pretty soon. I'm going to come out here. Now you can see the orange is a little bit more prominent. And you can see that it is 10 times darker. And you can see the sky is getting a little bit more blacker. Right? And now you're starting to see the contrast between the Earth, the atmosphere, and space. All right? So you can see that. I'm going to give it a little bit more trim. Push this right back up. And it's just seriously a waiting game, folks, and just making some observations. Now, see how we were at 80? And then we kind of moved over to 90? A little bit past it? Told you guys. Alright? And practice these orbits over and over and over again. Practice getting out into space over and over and over again. And you'll notice that as you keep doing these, you'll get a little bit better at it. And you'll understand it a little bit more. Okay? So here we are. We're about to hit 6,000. About 4,000 away. Now what we want to do is we want to make some observations, okay? And once we hit 6,000, we're definitely going to be a little bit more observant because we're only going to be about maybe 1,300 away from engine shutoff, okay? And we're going to shut off a little bit earlier. The reason why we're going to shut off a little bit earlier is because we are still going to be having a lot of momentum. And just because we turn the engine off doesn't mean that we'll still be climbing and accelerating. Remember, there's less surface area in order for us to interact with, so we'll be having less surface tension to push us back down to the planet, okay? Which reminds me, I'll go ahead and turn the rotation on. And because I have, obviously at this height, we no longer have any aerodynamic lift anymore. We're clearly on the rockets. If I was to turn it off, we're not that high yet. We'd fall right back into the planet, and we're not that fast enough in order for us to achieve the orbit. Okay, so I'm watching. Look at our circles. Now it's a nice circle. Remember, it was a squish grate before, and you can see where the line is prominent and it's pointing to the planet. So now it's starting to take some shape and form. Okay? Now it's starting to take some shape and form. All right. So here we are. 71, 72. I'll slowly back off. 73. 74 and 75. We'll just go ahead and slowly back off all the way. All right. There you go. We'll back that off right there. Okay, we've just killed our engines. And we'll let it stabilize. Ladies and gentlemen, we've achieved our first objective, and that is to get into space. Now, we are not completely up there all the way. We are still interacting with some of the forces. That's why we are still producing these hot gases. but you can see the sky is very black right now. Okay, I'll go ahead and turn all this off. This is stabilizing. We don't worrying about all that yet. I'll turn this off so you guys can see, and we'll just take a look around and look at the stars, huh? There's the sun. And this is basically what the astronauts feel. I mean, this is why they love getting into space. Right? This is the beauty of the space. This makes you realize, look at the billions of stars that are out here. Billions of stars. Okay? But that's another time and place. All right, so let's go ahead and hop back in here. I was already hop back in there, and I'll go ahead and turn on the heads-up display. This is stabilizing. We are climbing. I'll go ahead and put this back in a 0 pitch attitude, which is fine. Okay, cool. I got some time. All right. So now what I'm going to do is I'm actually going to teach you some terms. All right. Now, don't worry. It's a learning phase. So I'm going to go over here. And the first term I'm going to teach you right here. Now, this is the little computer that we saw over here. Remember this thing? Remember this guy right here? This is what we're looking at. This multifunction display right here, this orbit. Remember we went to select? We selected the orbit. Okay, these are all the numbers. Now, we're only going to focus on 3 to 4 terms in this whole thing. Okay, because I don't want to confuse the heck out of you. I don't want to confuse the heck out of me. All right, now here's what we're looking at. So the first term we're going to look at is one called apoapsis, which is this guy right here. Okay, apoapsis. Okay, and what that means, okay, if we have our orbit, pretend you have an imaginary oval. The very high point, the top point, the larger point is your apoapsis. Okay, the very top point, the high point is your apoapsis. Second term I'm going to introduce to you is periapsis. If the apoapsis is your top point and your high point, then your periapsis would be your low point. Exactly. So you have a high point and you have a low point. Okay? How can I explain this to you even more visually? Check out my hill right here. My buddy hill. Now, everybody's gone up a hill and come down a hill before in your life. If you haven't, go outside and try it. It's pretty fun. If I was to draw an imaginary circle or oval right here along this area, the top of the hill would be the apoapsis. The top of the hill would be the apoapsis. The bottom of the hill would be your periapsis. All right? Top apo, bottom peri. See that? Top apo, bottom periapsis. Okay? Now, any object in space that has an orbit around a body of mass has an apoapsis and a periapsis. The planet Earth has an apoapsis and a periapsis. In fact, we just had ours in July. Okay? We had our, now see how the oval is? We had our apoapsis July 3rd. We were 152 million kilometers away from the sun. Okay? 152 kilometers away from the sun. Now, the opposite of that, obviously, would be our periapsis. So where's our periapsis? Well, our periapsis is going to be in January. It's going to be 147 million kilometers away from the sun. See that? So your apoapsis was in July. Your periapsis is in January. Okay? Apo top, peri bottom. Apo big, peri small. See the oval? It's not a perfect circle. It's an oval. This is the shape of our orbit right here around the sun. Now, the way we measure this orbit in its shape and form is a term called eccentricity. Eccentricity. Right here. ECC. And we want this number to be 0.000. Okay, when it's the closer it is to 0, the more of a equivalent orbit and oval this thing will have. Okay, if the eccentricity has a higher number, then this oval has a deformed orbit. Okay, and we want to fix that. So those are the three terms for right now: apoapsis, periapsis, and eccentricity. Okay, apotop, peribottom, eccentricity, the shape of the orbit. Okay, now if I go back to orbiter and I try to find my apoapsis and my periapsis, okay, my apoapsis is telling me that I am 268.5 kilometers from the surface to where we are at currently in space. Okay, from the surface to where we are currently in space. Okay, that's cool. My periapsis, that was my top point. My periapsis is showing that I'm negative 98.66. Is that above the Earth's surface? No. That's below the Earth's surface. Negative, below. So what does that mean? Well, what that basically means is that you can even visually see it over here. If you look real closely, it's going to be kind of hard if you're watching this on a mobile phone, but if you're watching this on a computer, you can see it, that the orbit starts out fine. And then somewhere down the line, you see me crashing back into the Earth. Well, that's exactly what's going to happen here right now. We are going to be heading out this way. And then at a certain point in time, I'm going to be heading back down into Earth. I'm going to re-enter the atmosphere. Well, we want to achieve orbit. That's part of our objective today, right? Get into space. That's what we did. And achieve a perfect orbit. What? We got to achieve the perfect orbit. So how do we do that? How do we fix this? We have a problem here. We are not doing a perfect orbit. Okay? We're great out here. We're in space, but we're not achieving a perfect orbit. Well, how do I fix this? Well, it's quite simple, my friends. Quite simple. You ever heard the term, whatever happens on one side, the opposite and equal reaction happens on the other side? Well, that's the same thing how it works in space. Right now, whatever we do to our apoapsis side, our periapsis will see the effect to it. Okay? So what we need to do is we need to get to our apoapsis and perform what we call a burn maneuver. Once we perform the burn maneuver, okay, once that happens, and we perform the correct burn maneuver, the periapsis number will start to fall back down, and we will match what the apoapsis number is, because we want these two numbers to be equivalent, okay? We want the periapsis number to be 268.5. When that happens, the eccentricity number will be 0.000, which will tell us that we have a perfect oval. The apoapsis will say that we're at this level of height. The periapsis will say that we're at the certain level of height, so we'll be equivalent on both sides because our lowest part will be 268 and our highest part will be 268, and our eccentricity then will have to read out 0.0000. Okay? So, let's go ahead and perform the burn. Are we in the right state? How do we do it? What am I missing? Well, currently, we are not. Okay? What we need to do right now is we need to adjust our aircraft or spacecraft into the right formation. And remember these little buttons here on the bottom? I'm going to change this to green, by the way. Oh, that's not it. There you go. That's yellow. Oh, I like that blue too. Here's the green. The green. So what I'm going to do is I'm going to change this position of our actual spacecraft, almost said aircraft, so that we could perform the right burn maneuver. So here's some autopilot buttons on the bottom, and we need to put our spacecraft into a prograde position. So I'm going to go ahead and press this button here, and you're going to see that the spacecraft is going to change and turn around. And you can see that the thrusters will start to fire. Okay, there's one right there. You can see it firing. And it is putting us in this position right here. Now we are at the right level and the right position in order for us to achieve the orbit. And actually, we are actually in a very normally I start off at a very low orbit, but actually I'm at a very high orbit, which is cool because you get to see the continents a little bit more. But I'm in a very, very high orbit, by the way. All right, so let's go ahead and fix this periapsis. Now, when do I perform this burn maneuver? Do I just go ahead and fire the rockets now? How do I know when I'm going to reach to my apoapsis? Because Captain Zeewala, or Commander Zeewala, you told me that I need to get to my apoapsis and perform a burn maneuver. And once I perform the burn maneuver around my apoapsis, my periapsis will be affected. Well, that is correctly true. But how do I know when I'm going to get there? Well, last term, folks. Last term. See this one right here? Time to apoapsis passage. This is a countdown in seconds, APT. And we should be looking at this number. This number should be counting down. So if I go back here, and if I find the APT, here it is. I am 655 seconds away from reaching my apoapsis. Now, 60 seconds, obviously, times that, divide that by, or whatever this is. Obviously, it's going to be quite some time before we get to our apoapsis. So the cool thing about this thing is that it does have a time warp button. By pressing T, we've now accelerated by 10 times, and we are starting to move. Now, I don't want to go anything past this or faster than this because you can go by it real quick. So we'll do that, and we might actually go into night here, but we'll see. So once we get close to the apoapsis passage, and we have quite some distance covered, we have to cover negative 98 and then another plus positive 268 to get to that. So we'll probably start it at 60 seconds, and we don't need to use a lot of thrust, by the way, just a little bit. Okay, we are going into night. So we just need to turn it on just a little bit, and you'll notice that the periapsis number will start to move. All right, so here it is, coming up. Now we want to balance the burn as well, and I know this is a little confusing, but we want to do some on the apoapsis side before we reach it, and then we want to do some burn maneuvers on the the other side of the apoapsis side. All right, so here's 60 seconds. I went way past my mark. I'm going to go ahead and engage the thrusters. The thrusters are on. And you can see this number start to come down here. Now watch the periapsis number, folks. Now see, we don't have too much thrust going on. It's just a little bit. Just a tad bit that we're moving. It's nothing bananas. And the time to the apoapsis number is still coming down. If I want, I can give just a little bit more thrust. Now we are in a positive. Okay. And we just keep this number and we watch it. Now, if the apoapsis number starts to come up a little bit, we shut the engines down because we didn't engage enough thrust. Okay. So just continue to watch it. And we have a lot to cover. So here's 100. Okay, and the number's starting to come up. There's 200. Okay, it's going to reach 270. I'm going to slowly back down on it. And I will actually turn it down because we went way past our apoapsis point right here. But our eccentricity has gone down to 0.0015. Now we're no longer in, I'm going to go ahead and hit time warp again, and I'm going to go times 100, believe it or not, because we need to perform the burn maneuver again. If I want to be nitpicky, I can. But this is technically, it's still fine as well, but we want to perform a better burn maneuver so that we bring these two numbers closer together. Okay? Now see, it's not perfect, which is great because it's all about learning at the end of the day. All right? We're coming back into sunlight. The apoapsis number is starting to come down. And what I'm going to do is once I get to the point where I know I'm going to actually start the burn maneuver. Now, we only need to make up another 19. So what I'm going to do is I'm going to change this into coming up here. Here's 2. And I'm going to change this into the linear translation. Because I want to do just some small, tiny burn maneuvers in order enough for me to make up all of that 19. Because 19 is not that far. Okay, it's not that much. All right. So I'm going to go ahead and we'll start the burn right here. We'll wait to get to about 35 seconds. Roughly around that time. And now we'll go ahead and start the burn. And I'll actually use just tiny maneuvers right here. And you can see the number that's starting to change. So just small increments. And look at our eccentricity number start to fall. And now I'll make some tiny, tiny maneuver right here. And that's it. Now look at our eccentricity, 0.0000. Our apoapsis is at 269.9 kilometers, so we're almost 270 kilometers above the Earth's surface. Our periapsis is the same thing. It's 269.9 kilometers above the Earth's surface. So our low point and our high point are exactly the same. We have a somewhat oval, perfect oval, achieving orbit here. Okay, we've stopped climbing, by the way. We're really, really high up there. And that's it, folks. And our eccentricity is 0.000. So I no longer need to stay in the prograde. I can go ahead and switch back over to the horizon, which will keep us straight. I can turn off any of these guys if I want to, or keep them on. It doesn't matter. I'm not using any thrusters. And this will put us back in a straight and level flight. And if I wanted to, I can hit this button right here and click on map. And it'll actually tell me where I'm at, where the ISS is, where Mir is, okay, relative to where I'm at. So we're over here. And we're heading out this way. The continent should be here somewhere. Oh, it's on that side. You can't really see it. But here we are. Let's go ahead and turn all this stuff off for you. Turn this off. Turn this off so you can see it. And ladies and gentlemen, we have completed our objectives of getting into space and then achieving orbit. Huh? We did it. Now, I know this tutorial was a little bit long. I might try to ramble a little bit. Could have cut it short here and there, but it's the first of many. So obviously in this one, you gain the most information, and you try to absorb as much as you possibly can. So I try to convey it over as much as I possibly can. So if you sat through this thing, or if you watched it in chunks or segments, or even if you were like, screw this, just thank you for watching. I appreciate it. Thank you for giving some time. If you like what you see, go ahead and hit the like button. If you dislike what you see, hit the dislike button. Subscribe to stay updated on new video releases. Hit that bell button to be notified anytime I make an upload. Ladies and gentlemen, welcome to space. And we can stay up here in this particular orbit for years without coming back down. So thank you for staying up here with me. I appreciate it. This is Captain Zeewala. And, whoa. This is Commander Zeewala. And we'll see you, ladies and gentlemen, on our next one. Thanks for watching, folks.